So here we have a piece of cardboard 30 centimeters long and 25 centimeters wide is used to make a box without a lid, similar to what we did with our piece of paper. Each corner you cut out squares of equal size, then fold them up. And if we call each of these x, just like we saw before, length times width times height, we get an expression for our volume. So we just wrote a polynomial function to represent the volume in terms of x. If we were going to graph this function, again, it's already factored. So we know that our x-intercepts would be 15, 12.5, and 0. So we would know that those would be our x-intercepts. And overall, can you see the minus 2x, and x? That will make an x cubed graph. That will be positive. Basically, one of the things you can do to figure out what kind of graph it is forget about the coefficients or the numbers in front, except for the positives and the negatives, and basically say, here I have a negative x, here I have a negative x, here I have an x. If I multiplied those all together, I would get a positive x cubed. So I know that this is an x cubed graph. Each of these x-intercepts has a multiplicity of 1. So when I'm sketching the graph, I know it's going to come from down here and go through each of those x-intercepts, just like that. What's the domain? Well, the domain of an x cubed graph is normally everything, but now that we have a situation, only certain values work. And so our domain, does it make sense that x has to be bigger than 0? If you don't cut anything out, you're not going to make the volume of the box. Does it make sense that x has to be less than 12.5? If you cut out 12.5, you won't have any paper left to make a box. So our domain makes sense to be between 0 and 12.5. So what we're looking at is only this section of the graph. Now, to the nearest cubic centimeter, what is the maximum? This is a calculator question. You would have to go to your calculator, type in your equation, so 30 minus 2x (25 minus 2x) times x, and then graph it. Set your window so that you can see the domain that you want to see. You want to see between -1 and 12.5, so maybe I'll go to my x max and go to 15. As far as seeing, well, how high should I make my y max? You can guess and check here for a long time. Or another thing that's very helpful is if you go to second table, you can see how big the numbers get from 0 to 10 here. So you notice my numbers are already at 1,500. So I probably would have guessed 100, then 200, then maybe 500. And it would have taken me a while to get to a point where I say, oh, it looks like around 1,500 is a maximum. So I'm going to go back to my window and put something larger than 1,500. Maybe I'll go 2,000. I'm going to change my scale to go by 100s just so that it has nicer things. So there's our graph going through that x-intercept at 12.5. And now we can find the maximum by going second, calculate, number 4, the maximum. I'm going to use 2 as my left bound. I'm going to use 7 as my right bound. Yes, my maximum's in between there. So push enter. There we go. And it matches up perfectly with the graph that we had before. So x is 4.52, and the maximum volume is 1,512.043. So let's read the question in part C. What are they asking for? To the nearest cubic centimeter, what is the maximum volume? So I'll write that out. Max volume is 1512 centimeters cubed. That's to the nearest cubic centimeter. And then it says what size of square should be cut? Well, does it say to what decimal I should do? To the nearest tenth of a centimeter? No, it doesn't say what size. So the x equals 4.5 centimeters. And then it asks for the dimensions. It is 4.5 centimeters by, if we put 4.5 in for x, 30 minus 4.5, 21.0 centimeters times by 25 minus 4.5, 16.0 centimeters. Now, I was rounding, so I'm going to just double check to see if my decimals are right, because I used the 4.5 as a rounded value and then calculated my dimensions. I have a feeling that maybe I'm not correct to the nearest tenth of a centimeter because of that. So some things with your graphing calculator that you can do. Okay? One thing is we just found our maximum at x equals 4.52 and y is equal to 1512. I'm going to show you something. If I push x at this moment, right after I figure out my maximum, my calculator will temporarily remember your x from the last thing you solved. If you do any other calculation in between, 2 plus 2 is 4. Oh, 2 plus 2 is 4. I'm going to just see if my x is still 4.52. It is. Okay, sometimes it goes away temporarily, but it's still remembered that x was 4.52. So now I can check, is 30 minus 2x 21.0? No, it's 20.9. Is 25 minus 2x 16? No, it was 15.9. So I would have lost, if I would have written this as my answer because it asked to the nearest tenth, I would have lost a half a mark on my final exam because the answer should have been 4.5 centimeters by 20.9 centimeters by 15.9 centimeters. That's correct to the nearest tenth. Okay, the questions you can do are 3, 4, 5, 6, 9, and 10.